Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Al-Hafiz bin Muhammad Aminuddin. My matrix number is TB21057, and today I will show you about my project in BTE1212 Electrical Fundamental Laboratory project. So my project is about half wave and full wave rectifier circuit. So check it out. So now I want to measure the parameter using the oscilloscope. First you click the oscilloscope and then power on. So you run the list and you click to auto set, and then you click to the power at the button of run or stop. So we move the into the middle and we set the period. This is 20 milli per second, and then this is for channel 1, row for channel 1, and this is row for channel 2. So I want to set up and I arrange the waveform to the middle. Okay, so now we can see the waveform of the input signal and the output signal. Input signal is for the channel 1, which is blue color, and then the channel 2 is for channel 1 is yellow color, and then the channel 2 is blue color. Alright, so for the parameter that I want to know, I just click this widget and choose channel 1, and here, okay, first this is the frequency 50 Hz. So this is measured 50 Hz because I set the AC power to the 50 Hz, and then you can see the period. The period is 20 milli per second because of because I set the 20 milli per second per division. And then this is voltage peak to peak. So voltage peak to peak is 622 volt, and this is VRMS, voltage RMS, which is 290 volt. But here I use to 220 VRMS of AC power, but here it's shown that 290 volt. So you also can see the voltage max 311, and this is how I measured the parameter using the oscilloscope. This method I use this method is same that I used to the measured full wave rectifier circuit. So after I do my experiment, we can conclude difference between full wave and half wave. Full wave rectification and half wave rectification are two ways for converting AC to DC. In both situations, the rectification is performed by leveraging the diode's property that current flows only in the positive direction. Full wave rectification turns the negative component of the input voltage to a positive voltage, which is then converted to DC using a diode bridge setup. Half-wave rectification, on the other hand, eliminates just the negative voltage component before converting to DC using a single diode. Following that, the waveform is flattened by charging and discharging a capacitor, yielding a clean DC signal. Because the complete circuit is utilized, full wave rectification is more efficient approach than half-wave rectification. In addition, the ripple voltage that remains after smoothing depends on the capacitance of this capacitor and the load. With the same capacitance and load, full wave rectification produces less ripple voltage than half-wave rectification. It goes without saying that the lower the ripple voltage, the greater the stability. So my observation for this experiment is the rectifier is an important component in many electrical circuits. This is due to the fact that most electronic circuits run on low voltage DC, and it is more cost effective to deliver power in the form of AC. As a result, we require a gadget that can convert AC to DC. A rectifier is a device that transforms alternating current voltage to alternating current voltage pulses. The pulsing DC voltage is made up of AC ripples combined with DC voltage. As a result, it is known as pulsating direct current voltage. The half-wave rectifier turns half of an AC circle into pulsing DC, whereas the full-wave rectifier converts the entire circle to the throbbing DC. That's all from me. Thank you.